Alright, we're going to look at a fun topic here. Maybe a little frustrating at first, but the more practice you get with it, the more enjoyable it is. So it's kind of a fun little exercise. And so what we're going to do is solve a system of three equations, three linear equations, using its augmented matrix. In particular, what we're going to do is we're going to put this, what we're going to call augmented matrix, into reduced row echelon form. And we're going to do it, we're going to use, let's look at the example here. So we'll use Gauss-Jordan elimination to solve the system. Okay, use Gauss-Jordan elimination to solve the system. So those will be our instructions. Now, Gauss-Jordan elimination is the method by which you get reduced row echelon form. Okay, so I'll point those things out as we work through the problem. So the system we're going to solve is 3x plus 7y minus 15z equals negative 12. That's our first equation. Then x plus 2y minus 4z equals negative 3. And last we have negative 4x minus 6y plus 15z equals 16. Okay? So that's the system of three equations. And the first thing we're going to do is we're going to convert this system to what we call an augmented matrix. And the idea of an augmented matrix is, let me write this out for you, because these systems are very predictable, right? You've got all of your x's in a column, all of your y's in a column, all of your z's, all of your equals, and all of your constants over here. Okay, so they're very predictable. So when you're solving a system of equations, you really don't have to worry about where x, y, and z and the constant are, because they're consistently in the same place. So in your augmented matrix, you just focus on the coefficients. Okay? So I'll show you. It's maybe if you've done synthetic division with polynomials, you don't worry about the variables, you just focus on the coefficients because there's a pattern with the variables. Okay, so it eliminates a lot of writing. So for that's why I say for me this is kind of fun, because I get to solve a system without writing x, y, and z over and over and over again. Okay, so here's how you get your augmented matrix. And I'll explain why it's not just a matrix, it's an augmented matrix in a moment. So the first equation, actually, yeah, let's go ahead and do it this way. The first equation has coefficients 3, 7, negative 15, and negative 12. The second equation has coefficients 1. A lot of people get messed up here and think this coefficient is 0 in front of x, but it's a 1. Watch that. So 1, 2, negative 4, negative 3. And last we have negative 4, negative 6, 15, 16. Okay, so those are our coefficients. Now we need the proper notation to go along with it. So a matrix is enclosed within brackets on both sides, like this, enclosed within brackets. A system usually has a left brace to sort of enclose all of the equations that make up the system, but a matrix is enclosed on both sides by brackets. And then what makes it an augmented matrix, because right now this is just a matrix, 3 rows by 4 columns. An augmented matrix, to show that this represents a system, so that's an augmented matrix represents a system. A common way to indicate that is by putting a vertical line where the equals signs are in your equations. Okay, so those kind of match up. So don't forget your vertical bar when writing your augmented matrix. Okay, so now the question is, how do we solve this system? So how do we solve this system? And remember, to solve a system of three equations means to find an ordered triple x, y, and z, values for x, y, and z that make all three equations true. Okay, so that's what we're going to work on. How do we do that here? Well, our goal in Gauss-Jordan elimination, there's also Gaussian elimination. I'm opting for Gauss-Jordan elimination to fully take advantage of the matrix technique here, okay, is to get the matrix, the augmented matrix, in reduced row echelon form, okay? So in Gaussian elimination, if you were to explore that, it would just be row echelon form, not reduced row echelon form. And that technique has a mix of elimination and substitution. Gauss-Jordan, you just do elimination, and you do all your work in the matrix. And that's what we're going to focus on. So what is our goal here? What is reduced row echelon form? Let's take a look at that. So reduced row echelon form, what does it look like? Reduced row echelon form looks like this. Your first column is 1, 0, 0. Your second column is 0, 1, 0. Your third column is 0, 0, 1. And then you just end up with your x. These are constants, by the way, that you get over here, y and z. So when you finish this, the numbers over here are the ordered triple that make up the solution to the system. Okay, so that's what we want. We want to get this augmented matrix for this system to look like reduced row echelon form. So here's the strategy. So the first thing you do is you work on your first column. You get zeros in your first column. So you work on getting the zeros in your first column. The second thing you do is you go to the second column and you get your zeros. And I bet you can guess the last thing you do is you go to your third column and get your zeros, okay? Now, the last thing you do, so fourth, let's say, is make your ones. So you make your ones at the end. Those numbers could be anything initially, and then you make them ones by simply dividing each row by the appropriate number. So that's the strategy. So let's get started here so you can see this in action. It's going to take a lot of paper, so be ready for that. And don't skimp on showing work, because you don't want to make any mistakes. Even I, who does arithmetic in my head a lot, sometimes I'll double and triple check before I write my numbers down, because I don't want to make a mistake. Now, one thing I notice is over here in my reduced row echelon form, I'm going to start my first column, right? I'm going to focus on this guy, and I'd like a 1 to go in the top left corner. Well, remember, each of the rows here just represents an equation. So it doesn't matter what order those equations are in, it's still the same system of equations. And I've got a 1 right there. So one thing that might help me is to interchange row 1 and row 2. So what that would look like then is my row 2 becomes my row 1. So it'd be 1, 2, negative 4, negative 3. And then my row 1 becomes my row 2. 3, 7, negative 15, negative 12. And then row 3 didn't change. Okay? And lots of times when you write an equivalent matrix, you'll put this little tilde here to show that you get an equivalent matrix. Alright, so now that we've got that 1 there, which doesn't happen very often actually, that you would have to interchange to get the 1. And you don't have to do that, by the way. You could work with the 3 that's up here and then make it a 1 later. But so we do have our 1. So what do? We want to create zeros. We want zeros. So what we do is we take this 1 and we eliminate these guys in this first step. So you use the entry that shouldn't be 0, which in our reduced row echelon form in the first column, that's this guy, the top entry. So we use that entry to make zeros below. So the way we do that is I want my 1 and 3 to cancel somehow. So what I'm going to do is turn my 1 into a negative 3. So I'll take negative 3 times, and I have to multiply it by my entire row 1. Negative 3 times row 1 plus, and I'm going to add to that row 2. Okay? And that's going to give me my new row 2. So let's see what happens when we do that. Let's look at negative 3 times row 1. If I multiply all of row 1 by negative 3, I get negative 3, negative 6, 12, 9. And then I'll add to that, so this is negative 3 times row 1, and then I'll add to that row 2, so let me copy row 2 beneath it, 3, 7, negative 15, negative 12. I need to add those together, right? This is my row 2. And when I do this, I get 0 here, which is what I wanted, right? Because that's going to give me a 0 there in my row 2. Then the rest of it just gives me whatever numbers I get. So here I have 1, negative 3, negative 3. So that's my new row 2. But I also want to get a 0 where the negative 4 is. So I need to use my 1 again to eliminate the negative 4. Well, if I want to eliminate negative 4, why don't I turn my 1 into a positive 4? So I'll do that by taking 4 times row 1 and adding it to row 3 to get a new row 3. Okay? So let's see what happens if I multiply row 1 by 4. I get 4, 8, negative 16, negative 12, right? I multiplied row 1 by 4. And then I'll add to that row 3, which is negative 4, negative 6, 15, 16. And I get 0 again for my first entry. That's going to be right here in my new row 3. 8 plus negative 6 is 2. Negative 16 plus 15 is negative 1. Negative 12 plus 16 is 4. So now what I'm going to do is rewrite my matrix, my equivalent matrix. Now, I've got a new row 2 and a new row 3, so row 1 doesn't change. Row 2 is 0, 1, negative 3, negative 3. And row 3 is 0, 2, negative 1, 4. Okay? And you can see now, really, at this point, you would have zeros here, and this typically wouldn't be a 1, but we made a smart decision initially and made it a 1 very easily. Okay? So this column is done. So now we move over to the second column, and now I want zeros here and here. So what I'll do is I'm going to use this 1 to eliminate that 2, and then I'll use this 1 to eliminate that 2. Okay? So now I'm going to be taking this 1, and if I want to eliminate a positive 2, I'll multiply this 1 by a negative 2. So I'll do negative 2 times row 2. I'm focused on row 2 here because I'm using this guy to eliminate. So negative 2 times row 2 plus row 1, right, here's row 1, is going to give me my new row 1. So let's write that out. Take row 2 and multiply by negative 2. So I get 0, negative 2, 6, 6. And I'll add to that row 1, which is up here, 1, 2, negative 4, negative 3. So when I add those, I get 1, 0, that's what I wanted, 2, 3. And that's my new row 1. So you can see I'm going to have a 0 on my second entry of row 1, which is going to go right there when I rewrite my system, my matrix. Now I'm going to do the same thing and use this 1 to eliminate the 2 on the bottom. So I'll do negative 2 times row 2 plus row 3 to give me a new row 3, right? Row 1 and row 2 are the ones I want to change. So let's look at negative 2 times row 2. That's negative 2 times this row. I get 0, negative 2, 6, 6. And then let's copy row 3, which is down here. 0, 2, negative 1, 4. Adding those together, I get 0, 0. So there's my 0 that I was trying to create. 5, 10. Okay? Now, every row represents an equation. So in this particular case, I noticed that all 5 and 10 are both divisible by 5. So I'm going to divide by 5 here to make the numbers easier to work with. So that's going to give me 0, 0, 1, 2. So that's my new row 3 now. So I've got my new row 1 and my new row 3. So let's recopy our system, our matrix. Let's see, row 1 and row 3 changed, but row 2 didn't. So let me copy row 2, 0, 1, negative 3, negative 3. My new row 1 is here, 1, 0, 2, 3. And my new row 3 is here, 0, 0, 1, 2. Okay? So column 1 is I've got my zeros in column 1, I've got my zeros in column 2. Now what I want is my zeros in column 3, which will need to be up here. So luckily this turned out to be a 1 again. We're getting very lucky here with the 1s. I'm going to use this 1 to eliminate both of these guys. Okay, so now you should have the hang of this. So let's use row 3 to eliminate row 1. So in order to do that, I'm going to multiply row 3 by negative 2, and then I'll add it to row 1 to get my new row 1. So I'm turning this into a negative 2 to eliminate this positive 2. Okay? So that's going to give me negative 2 times row 3 is going to give me 0, 0, negative 2, negative 4. Add row 1, 1, 0, 2, 3. And I get 1, 0, 0, negative 1. And there's my 0 on my third entry. So that's going to be my new row 1. Okay? Then I'm going to use this 1 to eliminate this negative 3. So I'll do 3 times row 3 plus row 2 equals my new row 2. So 3 times row 3 looks like 0, 0, 3, 6. And row 2 is 0, 1, negative 3, negative 3. Adding together I get 0, 1, 0, 3. And that's my new row 2. So let's copy our new system, our equivalent system here. Row 3 didn't change, so I'll copy them down. 0, 0, 0, 1, 2 is row 3. Row 2 is 0, 1, 0, 3. And row 1 is 1, 0, 0, negative 1. And at this point, you've got all your zeros where you want them. That's the first thing you do, right? Zeros in column 1, zeros in column 2, zeros in column 3. Usually these aren't all 1s at this point. For example, you could have a 2 there. If that were a 2, all you would do to make it a 1 now is divide the entire row by 2. Because that wouldn't change your zeros that you worked so hard to create, but it would certainly make a 1. And then, so again, at this point, you would work on making your 1s by dividing each row by what you need to get the 1. But we got lucky and got our 1s. So what does this mean? How did this help us solve the system? Well, remember, each of these represents an equation. Each row represents an equation, right? So the first column is your x column, then your y column, then your z column. The first row represents 1x plus 0y plus 0z equals negative 1. Remember, the vertical bar is your equals. Well, that's the same thing as saying, if you simplify this, that just says x equals negative 1. So that tells us our x value. Similarly, row 2 is 0x plus 1y plus 0z equals 3, which tells us, if you simplify, that y equals 3. And see, there's our y value. And the last row says 0x plus 0y plus 1z equals 2, which simplifies down to tell us that z equals 2. So truly, when you get your reduced row echelon form, when the left side of your matrix looks like this, these numbers are your ordered triple. So the solution to the system is the ordered triple, -1, 3, 2, meaning that x, y, and z value are the only x, y, and z values that make the original system, make all three equations in the original system true. Okay, now I moved pretty slowly here. I'm sorry the video was so long. These problems are lengthy, and you want to make sure that you take your time with all your arithmetic and that you show your work, because the worst thing that can happen, not the worst, because we all learn from mistakes, right? But in these problems, you want to try to avoid mistakes as much as possible, because you don't want to do this more than once. You don't want to have to go back and try to fix these numbers. Okay, so practice with this and see how you do.